Now take a note on Gauss-Jordan method. Gauss-Jordan method not used generally. Gauss-Jordan method is not used for the solution of a system of equations as it is more expensive from the computational point of view from the computation point of view than the Gauss elimination method elimination method. See, in Gauss-Jordan method, what we have to reduce above and below the pivot value to 0. So more number of calculations are exist in Gauss-Jordan method than the Gauss elimination method. So computationally very cost Gauss-Jordan method. So generally, if I want to solve the system of equations, use only Gauss elimination method. But what is the purpose of Gauss-Jordan method? However, the main point is to find. It gives a simple method, Gauss-Jordan method. Gauss-Jordan method. Actually, Gauss-Jordan method is popular to find the inverse of the matrix. Gauss-Jordan method gives a simple procedure or simple procedure for finding inverse of a matrix. Okay, what is the method here? Or how to find inverse of the method? Write the augmented matrix of A. Write the augmented matrix of capital A with the identity matrix of same order. With the identity matrix of same order. Okay, identity matrix. What is identity matrix? Represented by capital I. Then use Gauss-Jordan method. I will write like this. Use Gauss-Jordan method to get the following. What is that following? Matrix A and I. This is augmented matrix. It is reduces to what? A must be reduces to I. And this I automatically reduces to A inverse by applying what method? Gauss-Jordan technique. The meaning is what? Write matrix A. If I consider 3 by 3 matrix A and identity matrix 0 0 1 identity matrix. Okay, apply Gauss-Jordan technique, then it reduces to what? Here you have to get identity matrix. Okay, and here you will get what? A inverse. Whatever this matrix is there, this matrix gives what? A inverse. This entire matrix is A inverse. And one more important point is apply only row transformations or row operations. Okay, let us do one problem based on this. Now take one problem. Find the inverse of the matrix. Okay, using Gauss Jordan method. Using Gauss Jordan method. What is the matrix is A equal to 1 1 1 4 3 minus 1 3 5 3 3 5 3. Solution. And let me include both the cases. Gauss Jordan method using first one without partial pivoting, second one with partial pivoting. Okay, now first thing, write the augmented matrix. Consider the augmented matrix. What is that matrix? Matrix A and identity matrix written side by side. So I'm again writing this AI. So 1 1 1 4 3 negative 1 3 5 3, and the identity matrix of 3 by 3 0 0 1. Clear? Now what is the first one? Without partial pivoting. What is the meaning of without partial pivoting? Means proceed as usual. No need to take maximum value to the 1 1 position. Okay. So what is the first operation? First I have to consider these two elements to 0 using this 1 1. Okay. Take, what is that, R2 minus 4R1 and R3 minus 3R1. Then what is this matrix? Augmented matrix becomes, there is no change in the first row, so 1 0 0, and these two become zeros, and this one 3 minus 4 negative 1, and this becomes negative 5 minus 4, and this is 1, and this is 0. Next one, this is already 0 using this third R3 minus 3R1. This is 5 minus 3 2, right? And this is 3 minus 3 0, and these values, this is 0 minus 3 and 0 0, and this is 1 0. This is the matrix. Okay, next one, after getting this, now this is 2 2 position. What I have to get, what is the logic here? AI, it must be reduces to what? I A inverse. That means I have to convert this matrix A to identity matrix. So this matrix A must be converted to identity matrix. For this I have to reduce this 1 0 0. First identity column is already over. This is the first identity column. Now I have to get what? 0. Here I have to get 0, and this is 1, and this is 0. So first make this negative 1 to positive 1. Okay. So next operation is what? R2 divided by minus 1, or R2 multiplied by minus 1. So take, now minus 1 into R2, this reduces to what? This is 1 1 1, first row as usual, right? Second row, now this multiplied by minus 1, so this is 4 negative 1 0, and this value 0 2 0 minus 3 0 1. Okay, this is over. Next one, what? Using this key element, reduce this position to 0 and this position to 0. So what is the operation now? Take, what is the first one? R1 minus R2. R1 minus R2 means the change belongs to first row. Okay, next one, R3 minus 2 R2. R3, this is R3 minus multiplied by these two and subtract. Then it gives what? This is 1 1 1 1 0 0. Second row, sorry, there is a change in the first row. Okay, so what is this? Becomes 1, and this reduces to 0, isn't it, right? R1 minus R2, so 1 minus 5, this becomes minus 4. Next one, R1 minus R2, this is minus 3. Next 1, next 0. Coming to second row, there is no change in the second row, so as it is. Third row, there is a change. This is 0 and this becomes 0. R3, 0 minus 10. 0 minus 10. So this is minus 10, and this is minus 11, and this is 2, and this is 1. right? Now see, the first identity column 1 0 0 is over, 0 1 0 over. Next I have to get 0 0 1. So convert this element to 1. Next step, so what is the operation? Take r3 divided by minus 10, r3 divided by minus 10. So no change in the first two rows, so write as usual, minus 3 1 0 0 1 5 4 minus 1 0 0 0, this is 1, and what is this becomes 11 by 10, and this is becomes what, minus 2 by 10, minus 2 by 10, and this becomes what, minus 1 by 10. This is also over, right? And let me write here, what is the next operation after getting this one 1, after getting using this value, convert this to 0 and this to 0. So what is the operation? First row r1 plus 4r3, this is minus 4, so this becomes plus 4, add it to first row 0. Next one, this is r2 minus 5r3, r2 minus 5r3 gives what, I'm writing here, gives this one, what is this, the change in first row is, this is 1 0 0, and this is 0 1 0, this is 0 0 1. Now I got identity matrix here. See what the changes on the right side matrix. This is what, uh, this step is, next term, this is what, minus 14 by 10, this is 2 by 10, and this is minus 4 by 10. Second row minus 15 by 10, next 0, next 5 by 10. Third row 11 by 10, minus 2 by 10, next minus 1 by 10. Is what form? Is of the form I slash A inverse, I slash A inverse. Therefore A inverse equal to what, this is minus 14 by this minus, this is plus, not minus, plus, so this is multiply 7 by 5, 7 by 5, this is 1 by 5, this is minus 2 by 5, and this is 3 by 2, this is 0, this is 1 by 2, this is 11 by 10, minus 1 by 5, minus 1 by 10. This is A inverse. Okay, this is without partial pivoting. Now second case with partial pivoting. With partial pivoting, what is meant by partial pivoting? You know that clearly. I have to pick the largest element to 1 1 position, right? So first let me write what is AI. What is AI? 1 1 1 4 3 negative 1 3 5 3 1 0 0 0 1 0 0 0 1. Okay, next one. Now here what is the, in the first column, what is the largest element? 4. I have to bring this 4 to, I have to brought this 4 to A11 position. So what is the operation? Interchange first row and second row. Okay, this gives what, this is 4 3 minus 1 0 1 0 1 1 1 1 0 0 3 5 3 0 0 1. Okay, this is over. Now next step, I have to, let me convert this first position to 1. Okay, simple, to get calculation very easy, to get identity matrix. Now here I have to get identity matrix, so this must element must be 1. So r1 divided by 4 I am taking, r1 divided by 4, what this gives, 1 3 by 4 minus 1 by 4 0 1 by 4 0. No change in the remaining rows, 3 5 3 0 0 1. This is over, right? Next step, after getting this one, using this one, convert this to 0, this to 0. So what is the, what are the operations? Take r2 minus r1 and r3 minus 3r1, r3 minus 3r1. It gives what, this is 1. I have to apply only row operations, remember this. 1 3 by 4 minus 1 by 4, this is 0 1 by 4 0. Next one, this becomes, this is, these two become 0 using the operations, right? and the remaining positions are, this is 1 by 4 you will get, and this is 5 by 4 you will get, and this is 1 minus 1 by 4 and 0, and coming to this 11 by 4 and 15 by 4, next 0 minus 3 by 4 1. Okay, next what is the next chance? I have to convert this a2 to 1, a2 to 1. For this what I have to take, and no, first I have to bring in this column, in the second column, bring the largest value to a22 position. So take 11 by 4 to the position of a22. The largest value in second column is 11 by 4. So what is the operation? Interchange second row and third row. So this is 1 3 by 4 minus 1 by 4 0 1 by 4 0. Now this is 0, this is now 11 by 4, this is 15 by 4 0 minus 3 by 4, next 0 1 by 4 5 by 4 1 minus 1 by 4 1. Okay, to get now what is the pivot value? This 11 by 4 is the pivot value, 11 by 4 is the pivot value. So let us make this pivot value to 1. So for that, take what is the next operation? R2 divided by 11 by 4, R2 divided by 11 by 4, what it gives? 1 3 by 4 minus 1 by 4 0 1 by 4 0, and this is 0, this is 1. 15 by 4 by 11 by 4, 15 by 11, isn't it? Next one, this is 0 3 by 4 by 11 by 4 minus 3 by 11, and this is 4 by 11, and there is no change in the third row. This is 0 minus 1 by 4 1. Okay, next. Now after getting the a2 to position 1, reduce the second column positions to 0 by taking operations r1 minus 3 by 4 r2, r3 minus 1 by 4 r2. Okay, then what is this becomes? Matrix becomes what? This is 1, and now this position 0 minus 14 by 11, this value, and coming to this 0 5 by 11, and this is minus 3 by 11. Coming to second row, there is no change, this is 15 by 11, this is 0 minus 3 by 11, and this is 4 by 11. Third row there is a change, 0, and this becomes 0 now. Okay, these two positions reduces to 0 by taking two row operations, and 0 0, and this becomes what? 10 by 11, and this is 1 minus 2 by 11 minus 1 by 11. This is over. Now in the third column, what is the highest value in magnitude without considering? Highest value in magnitude, what is that? This is 14 by 11, this is 15 by 11, right, and this is 10 by 11, right. And remember one more point, if you interchange here, there will be a change in identity matrix, there will be the change in the identity matrix. So at this stage, after getting these two identity columns, directly convert this element to 1. Okay, so r3 divided by 10 by 11, r3 divided by 10 by 11 reduces to what? This is 1 0 minus 14 by 11, 0 5 by 11 minus 3 by 11, 0 1 15 by 11, 0 minus 3 by 11 4 by 11, and this is 0 0 1. Now what is this becomes? Divided by means 11 by 10, and this is minus 2 by 10, right, and this is minus 1 by 10. Okay, why I am not shifting? Because at the last level, after getting two identity columns, if I get the highest value means this 15 by 11 comes here. When 15 by 11 comes here, there is a change in these two positions also. So no need to convert the last column, third column. Directly you make this value to 1. Okay. Next, lastly, use now what is the key value here? Pivot value. Using this, convert this to 0, this to 0. That is the last operation. So what is that operation now? Last operation, r1 plus 14 by 11 r3, and next one r2 minus 15 by 11 r3, right? What this gives, I'm writing here, gives, this is reduction symbol actually, okay? So gives this one reduction symbol, this like this reduction matrix reduces to, this is obviously we are getting identity matrix here, right? And what is the change here? Let us see. This is 7 by 5, 1 by 5, minus 2 by 5, minus 3 by 2, 0, 1 by 2, and the third row is 11 by 10, minus 1 by 5, minus 1 by 10, minus 1 by 10. Lastly, therefore, what is this matrix, this structure? This is I A inverse. Therefore, what is A inverse equal to? Same value, same matrix with or without partial pivoting. Answer must be same. Always remember, A inverse is always unique. If you get different answers, means it is a mistake. 11 by 10 minus 1 by 5 minus 1 by 10. This is A inverse with and without partial pivoting. Okay.